Hi guys, today I'm here to show you how to create a deepfake in 2020. We will use Deepfacelab created by Hyperov, a Russian programmer. And to download this program, it's very easy. We just need to go on Deepfacelab GitHub repository and click on download. Here it's written releases, and we just need to click on mega.nd and download the latest version that currently is this. So after the download, we will find this executable file. We just need to choose the destination path, and it will extract on our file. So as you can see, this program is available also for Linux and other operating systems. Google Colab is a platform to allow students, for example, to elaborate artificially intelligent model. So now I'm on Windows, so I will download this version. But if you have Linux, you can also download the repository for Linux user, but take care to the fact that it's less updated than the Windows edition. So after the extraction of the file, we will have this folder called Deepfacelab NVIDIA. To the first impact, it seems very hard to understand because Deepfacelab has not a graphical interface. So, but I'm here to explain to you how to use this software. So, first things, in underscore internal folder, for us it's basically useless. In fact, inside this folder there are just files useful for program, and inside Deepfacelab there are the source file of the program. After workspace folder, it's very important folder, and right now it's empty, but it will be full of images, and after I will explain. And these are all the script that we will execute to create our deepfake. As you maybe saw, each script has the own number 1, 2, 3, and so on. This is the order in which you should open this script that are just batch file. In fact, inside this there are just a call to the Python program. Just set the local environment, and it's called the Python file. So nothing of special. So first thing, clear workspace is basically useless. It's needed just if you have already full workspace and you want to clear. So for now it's useless. Extract image from video data sources. This is the first thing that we have to do. And now I will show to you our video data. So like as data source, we will use this video of Putin. It's very close to the camera, videos, and it's long, almost 2 minutes. And as data destination video, it's President of France, Macron. It's 1 minute video. So we have to open workspace and put these two videos inside. Okay, take care to call this video data destination and data source, written data underscore source and data underscore DST. Okay, so now we need to extract images from video data source. As you can see, we need to choose how much frames per second we must extract from the video. This is the source, so it's put in video, and if we open properties, we can see that this video is at 30 FPS. So it means that if here I press zeros, I put zeros in the keyboard, it will extract 30 image for each second of the video. For me, it's good, so I don't have problem. I can just press enter, and in all Deepfacelab, if we just press enter, the program will use the default value, that in this case it's 0. The default values, it's always what is inside this square brackets. So I press enter to the keyboard, and now we have to choose the format. I will choose PNG, that it's the default. As you can see, now is extracting frame from the video, and it is using a software called FFmpeg. In fact, if I open Activity Manager, I can watch that inside here. Okay, Windows sometimes is a little bit bugged. Okay, there is FFmpeg, this executable software file is running, and we can find it here. Okay, now we just have to wait. Okay, we have the images. We can press enter. So if I will open this workspace folder, in data source folder, we can see that there are a lot of preview, a lot of images that are all frame of the video. They will be 30 for each second. Okay, now we have to extract all the frame from the data destination video. And this is the script. The script number 3: extract image from video data destination full FPS. Why full FPS? Because from the video destination we need to have all the frame of the video, or there will be holes in the face substitution. So in fact we'll just choose format. Okay, now we can press enter. And now inside workspace, inside folder data destination, we will have the same things. All the image, all the frame of the video converted to image. Okay, now what we have to do, or better, what the Deepfacelab will do for us. For each of these image, we will understand what is the face of this image, like where is the lip, where are the lips, where are the eyes, where is the nose, where are the eyebrows. For example, in this moment we have 2 faces. What will be the correct one? We will see. So exit from this workspace folder, and we must open this script called data source facet extract. There are 2 versions. The first one is the manual, full manual, so we should select each frame, and this is the automatic one. So we open this. This will be the data source video, or better, put in video. Okay, first very important things. We should choose the area of the face that we should individuate in the data recognition. So default value is wall face. The other value are full face, that is just F, and add that it's pretty new things. Basically, it substitutes all the face with air too. If we press interrogative point, we can watch the documentation of each. By the way, I will choose default. Now we have to choose our GPU. We can also use GPU, but CPU, sorry, but GPU with GPU it will be a lot of more faster procedure. So I will choose default one again. Here it asks us if we want debug images, but we don't really need debug aligned images of data source. We just need of data destination. In fact, for data destination is pretty automatic. So we press no. Okay. As you can see, it's a very heavy workload for our GPU, and it's also very long procedure. So we have to wait a lot of time. In the meanwhile, I'll show to you the utilization of GPU. Look, GPU go to the maximum, or almost. And this is the quantity of VRAM used. Is 5 giga and 500 megabytes of video memory. So if we have a graphic card with 4 gigabytes, the processor will be slower, because data must be transferred in the video card, then elaborated, then again to the hard disk, then from the hard disk to the VRAM, and from the VRAM again to the hard disk, and so on. While more video graphic memory you have, faster the procedure will be, because you need to do less swap. Okay, now as you can see, it's written image found 3000 and so on, and face detected the same number. That it's perfect. There are no error in the face recognition. So now we will open data destination facet extract. As you can see, there are 3 scripts this time. This is totally automatic, this is totally manual, and this is an hybrid, because it's basically the automatic recognition. But if there are multiple faces in some frame, or it don't or the software doesn't recognize a good type of face, ask the user to recognize it. So we'll do this, that is the better. So again, wall face and GPU. Okay, so also data destination video is added, but in this case, as you can see, there are more face detected than image found, because as I already showed to you, there are also the face of the woman to the right of the video, so there are more faces that image. So now a very important thing is to clear our dataset. So how to do? First of all, we should control all the data source and data destinations image. So we have data source view aligned results. This is a software that Deepfacelab offer to us, and it needs to watch all the preview images and thumbnails of the image in much more faster of what Windows Explorer allows us to do. Look, we can watch almost in real time. And in the case of Putin, it should be all good faces because the video was already cut from me, so no problem. Okay, now we'll see data destination. So data destination view aligned result. Oh, look, here it's a problem. There are more faces. More specific, there are faces of two persons. So we should delete all the faces of that woman. How to do it? We have a very powerful tools to do it. It's called data destination sort. Data destination sort, it's useful. It's needed to sort images for something. In this case, we will sort images for histogram similarity. That is also the default options. It means that the most similar faces are in the to the start and the most dissimilar to the end. We can also do the option number 5. This is dissimilarity and is the opposite of similarity. And we have also other algorithms like best face is faster, absolute pixel difference, one face in image, and so on. So if we want to perform a clean of our dataset, we can use also more than one algorithm, of course. But in this case, histogram similarity should be enough. So now we will open again data destinations aligned results. And as you can see now, we have all the face of Macron together. And we will go to delete all these faces. So from here, shift, right button, delete. Okay, now the dataset is clear. Now I show to you my method to clear our workspace better. Basically, in this case, should be useless, but in other cases can be a lot useful. What we have to do? So first thing, we have to sort our data destination, and we have just do it. But I will do it again, just in case. They should be already sorted. Okay, now you must watch again aligned results, and in our case are all good. Then delete or false positives, incorrectly aligned or rotated face, and the face that you don't want. Then we must open 5.2 data destination recover original file name. Okay, perfect. Now we have to go in workspace, data destinations, align and press Shift plus right button of mouse and open PowerShell windows. Okay, now we have to insert this command that I will leave in the video descriptions to delete all these underscore zeros in the name of the image. Okay, it's finished. I can close. Perfect. Now go one step behind and we have to create a copy of aligned debug. So copy, paste. Okay. So now we have to open alignment again. Select all the images with Ctrl plus A, copy, and paste them inside alignment debug copy. Paste. Now we have to substitute. Okay, and now we don't have to click because there are a lot of images selected. We have to delete. So press del button. Okay, now in my case this folder is empty. If this folder is not empty, we'll have to select inside this folder images, copy them, go inside aligned debug, right click, paste, and like before, we have to click on replace and then delete that image. After this, you should come back here and click on data destination facet manual re-extract deleted aligned debug and wait some moment. In my case, if I perform re-extract frames, found zeros image, so it's not my case. If some images have been found, you must, with your mouse, select the face that you want to extract manually. So a program it will be open, but it's not my case. Okay, after this, it's the moment to create manual mask of our faces. This is our first train that we'll do. This is just because I want to use XSeg method. And as I already said, I'm not sure of the results of this deepfake, so it's totally surprised. So now, if we want to use these XSeg algorithms, we should create before mask for data destination and for data source. The order is not important. So data destination mask edit. Okay, running XSeg editor. Okay, now this is an editor, and in this editor we have to create mask for our face. Of course, as you saw, we have 1,500 images just for this president. But this algorithm it's able to understand a model from just few manual models. So for example, we have 1,000 images, and from 10 or 15 manual mask, it will understand all the 1,000 images. So what we have to do? First, we have to select this to the left and then draw a mask for all the face because we choose wall face. So it means that we just don't have to select air. Maybe it's too much. Wait. I don't know how this deepfake can be, because the face of these two presidents is totally different. This is long face in vertical, and Putin is it's not so longer. So we have to, with D and A button of keyboard, we can go right and left, and we should create mask just of very different expression of president. So like this is different. So modern expression, different angle, points of view of the face. Here, 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 here. It's not so necessary that you have to be so precise to do this work. Now we can close and open data source mask for XSeg training. Okay, as you can see, for Putin face there are a lot of more expression and different point of view of the face. Like here is frontal and here is not more frontal. So we should give to XSeg algorithm, in this case, how is the face, the mask that it should create. Okay, now in this case, Putin puts the fingers on your face, on his face. So you should say to the program, to the model, that this is an obstacle. So we first create a mask for the obstacle. Actually, it should not be so much important from the source mask, but more from the destination mask, but we will do the same. Okay, we finish the the data source masking. So now we should train this mask. This is our first training, and this training is much more lighter than the training that we do to create the final mask. So we choose our GPU, we choose our face type, sorry, Okay, now is loading data source samples. Now it will loading data destination samples. Okay, as you can see, it found 27 segmented samples that are our mask that we created with how to say, in manually mode. Okay, the train is started. And wait, I open this in this way, it is clear. Here we can read the number of iteration, and this is the time for each iteration, and this is a value called loss value. More lower it is, better it is. And as you can see, now it's not even so high, it's just 0.2. Usually in the first iteration is 0.4 or 0.5. Never it's 0.3, but we are already at 0.1 and something. So it's already a good result. By the way, as you can see, in the model summary, we don't have so much option because it's just model name XSeg, face type wall face, and batch size 4. The batch size is the number of the face that each iteration our graphic card will calculate. And this is the training preview. With space, we can change our preview. Now it is XSeg training phases. Now it's XSeg source phases. Now it's XSeg destination phases. And to the left, we have just the frame, our image. To the center, there is the what our model is training. How to say, what our artificial intelligence has learned until now. And to the right, the final result. It's this plus this to the center together. This is, and here, as you can see, there is the current iteration number, that it is 1 because we never press the P button on the keyboard. In fact, we can press P to update the current training preview. Now we are to the 310, so I press P. Look, iteration number 524, sorry. And this is what our artificial intelligence has learned until now, and it is a lot of more precise than before. Look, the border are dark, are black, and the face, the mask that it is creating, is white. I can change preview. Now is training phase. Don't take care that the shape, not the shape, like the face inside the mask is it's strange, it's pretty fun, it's distorted. It's normal because this is not a training for the face, but is a training for the mask. So no problem. Okay, now I will press again P. I'll change preview. Look, it's good. Yes. So now of this training, we should arrive at least at 15,000 iteration. And during this training, we should press sometimes P button on the keyboard to watch if the training of the mask is good. So now I let my computer train. Okay, there's a problem with the mask here. So let's stop the training and apply the learned mask to both the destination and the source. Now we are going to create more manual masks to try to fix the model. Now that the mask is well formed, we can finally start with the training of the final phase, obviously only after applying the changes to the newly learned mask. Here, we can choose two different trainings. The first one is the Quick 96. It's the fastest and it's fine for video cards up to 4 GB of video memory. The second one is the one we're going to use and it requires at least 6 GB of VRAM on average. Obviously, also the second one can be set to consume less than 4 GB of VRAM, but it's a useless choice. Now, the first thing we will do is enter the model name if it does not already exist. Then, we have to choose which device to use. Then, we have to choose how often to create new backups. Initially, we will choose never to create it. Write preview history to 0. As maximum number of iteration now, we are not interested in entering a number. Flip faces randomly activates when data source expression don't cover enough directions, and then the Deepfacelab will try to turn and rotate images automatically to get more data input. As already said, the batch size would be the number of images processed and compared for each iteration. The higher the number, the more video memory will be needed. In this case, I will activate very few settings, so even 14 should be fine. The choice of architecture is a very important step. To understand a bit more, I suggest you to consult the official guide on Deepfacelab forum. In this case, I will choose LIEE. Also for the dimension of the encoder, decoder, and autoencoder, you can consult the grid. Masked training activated because we are using wall face. Highest priority? Not, because it doesn't help with generalization and slows down iteration time. The learning rate dropout is activated only towards the end of the training. The random warp of samples is kept activated for most of the training time. It is deactivated to activate the learning rate dropout. The GAN models does not have to be activated, but it is recommended to activate it only at the end of the training, because it makes the training very heavy and needs a well-generated phase. The gradient clipping must always be kept activated and, if it slightly increases, the iteration time. The training preview is very similar to the training interface of the XSeg mask. At the bottom right, we have the loss value of the destination and source, while the graphical interface has 5 columns that represent in order source phase sample, learned source phase from that sample, destination phase sample, learned destination phase from that sample, and result phase. To find the right batch size, we can do a simple calculation, that is, time for each iteration divided by the batch size. When we find the lowest possible number, it means that we are using the best batch size for the configuration used at that moment. By deactivating the random warp, we have achieved an increase in the generalization of the phase. We will now try to activate the learning rate dropout. To do this, however, we will need to decrease the batch size. Okay, we reached almost 300,000 iterations, and the values don't go lower than this. So now we'll go to try to merging mask with the final video and to see the result. If the result is not good, I'll try to use the backup before activating highest priority. So now I stop training and I open Manage SAEHD. I choose the model, I choose GPU. Okay, I now will choose Interactive Manager. Okay, this time I press yes, but you will not see this question because I already tried to match. So no. Okay, this is the merger view, and these are the key to control the merger. So now I press tab, and this is the view. So now I will change the type of mask. So I press tab, mask mode X. So I press X. Look, mask mode is changed, and I choose XSeg multiplied XSeg destination. So what can I change? Now I erode a little bit the mask. And now I blur the mask. Okay, now I try to change a little bit color transfer mode to see if there are other better algorithms. This is bad. This is bad. This seems good. This is bad. This seems pretty good. Okay, we try to activate sharpen mode. Okay. Now we augment super resolution. Okay, and should be good. Also, if the quality of the mask not so of the face is not so good, face scale is good.
I deactivate for a little bit super resolution.
And now we will press Shift plus interrogative point to save configuration up to the last frame. And then Shift plus square brackets Okay, the merging is finished, so now we can press S. Now we see the FPS of the megabit per second of the video. Just 1000. So we click on merge to MP4. We can do 2 megabit per second. And finally, this is the result.
And women, fellow citizens. For some weeks now, our country has been facing the spread of a virus, COVID-19. It has infected a number, a few thousand, fellow citizens. And this evening, I want to...
As you can see, we have some problem with the chin. That Macron chin is a little bit longer because the shape of our face are totally different. So we should work with other post-processing software to adjust. And the other problem is left eye, but maybe we can fix with more train and different options.
Share with you how my thoughts go out to the families and friends of those who are affected. This epidemic has touched all continents of the world and is affecting all European countries. It is one of the most serious health crises that France has ever known for a century now. In a large number of cases, COVID-19 is of no grave danger. Yet, it can have very serious consequences, especially for those men and women in France who are elderly or who are suffering from chronic disease, such as diabetes, obesity, or cancer.
Françaises, Français.
French men and women, fellow citizens. For some weeks now, our country has been facing the spread of a virus, COVID-19. It has infected a number, a few thousand, fellow citizens. And this evening, I want to share with you how my thoughts go out to the families and friends of those who are affected. This epidemic has touched all continents of the world and is affecting all European countries. It is one of the most serious health crises that France has ever known for a century now. In a large number of cases, COVID-19 is of no grave danger. Yet, it can have very serious consequences.
Françaises, Français.
French men and women, fellow citizens. For some weeks now, our country has been facing the spread of a virus, COVID-19. It has infected a number, a few thousand, fellow citizens. And this evening, I want to share with you how my thoughts go out to the families and friends of those who are affected. This epidemic has touched all continents of the world and is affecting all European countries. It is one of the most serious health crises that France has ever known for a century now. In a large number of cases,
Françaises, Français,
French men and women, fellow citizens. For some weeks now, our country has been facing the spread of a virus, COVID-19. It has infected a number, a few thousand, fellow citizens. And this evening, I want to share with you how my thoughts go out to the families and friends of those who are affected. Have very serious consequences, especially for those men and women in France who are elderly or who are suffering from chronic disease, such as diabetes, obesity.